Download this code from codegive.com, link in the description below. Local versus global variables in C, a comprehensive tutorial. Understanding the scope and lifetime of variables is fundamental in C programming. Local and global variables are distinguished based on where they are declared and, consequently, how long they exist during program execution. This tutorial delves into the concepts of local and global variables, explaining their characteristics, scope, lifetime, and best practices for their usage, with code examples to illustrate each point. 1. What is a variable's scope? A variable's scope defines the region of the program where that variable is accessible. In other words, it dictates where you can refer to a particular variable and use its value. Variables declared in different scopes can have the same name without causing a conflict, as the compiler distinguishes them based on their location in the code. 2. Local variables. Local variables are declared inside a block of code, typically within a function or a compound statement, code enclosed in curly braces. Their key characteristics are: scope local variables are only accessible within the block in which they are declared. They are not visible outside that block. Lifetime local variables are created, memory is allocated, when the block is entered and destroyed, memory is deallocated, when the block is exited. Storage local variables are usually stored on the stack. The stack is a region of memory used for managing function calls and local data. Initialization if a local variable is not explicitly initialized, its value is undefined. This means it contains whatever garbage value happens to be in that memory location. It is highly recommended to always initialize local variables to avoid unexpected behavior. Example Explanation local var is declared inside the myFunction function. It can be accessed and its value printed within myFunction. However, when main tries to access local var, the compiler throws an error because local var is not in the scope of main. Another example with nested blocks Explanation X is declared in main and is accessible throughout the main function, including the inner block. Y is declared within the inner block and is only accessible inside that block. Once the block ends, Y is no longer in scope. 3. Global variables. Global variables are declared outside of any function, typically at the top of the C file. Their key characteristics are: scope global variables are accessible from any function in the program, within the same file, and potentially from other files as well if properly declared and linked, more on that later with the extern keyword. Lifetime global variables exist throughout the entire execution of the program. They are created when the program starts and destroyed when the program terminates. Storage global variables are stored in the data segment of memory. The data segment is a region of memory dedicated to storing global and static variables. Initialization if a global variable is not explicitly initialized, it is automatically initialized to 0 by the compiler. Example Explanation global var is declared outside any function, making it a global variable. It is accessible and modifiable from both main and myFunction. The output demonstrates that changes made to global var in myFunction are reflected in main. 4. Variable shadowing, name collisions. When a local variable has the same name as a global variable, the local variable shadows the global variable within its scope. This means that within the local variable's scope, the local variable takes precedence, and the global variable is not directly accessible by its name. Example asterisk. Explanation asterisk. Asterisk both main and my function have variables named global var. Asterisk inside my function, the local global var, initialized to 10, shadows the global global var, initialized to 20. Therefore, printf within my function prints the value of the local variable. Asterisk outside my function, global var refers to the global variable, so printf in main prints the value of the global variable. Best practice asterisk while variable shadowing is valid c, it can lead to confusion and bugs. It is generally recommended to avoid using the same name for local and global variables to prevent ambiguity. 5. External linkage and the extern keyword, multiple files. When dealing with multiple C files, global variables can be shared between files using external linkage. By default, global variables have internal linkage, visible only within the file where they are declared. To enable external linkage, you need to 1. Declare the global variable in one file. Definition: this is where the variable is actually allocated memory. 2. Declare the global variable in other files. Declaration: use the extern keyword in other files that want to access the global variable. This tells the compiler that the variable is defined elsewhere. File 1, file1.c. File 2, file2.c. Explanation asterisk. Asterisk shared variable is defined, allocated memory, in file1.c. Asterisk in file2.c, shared variable is declared using extern int shared variable. This tells the compiler that shared variable is defined in another file and to look for it during linking. Asterisk when the program is compiled and linked, the linker resolves the reference to shared variable in file2.c to the definition in file1.c. Asterisk changes made to shared variable in file1.c are visible in file2.c, demonstrating that they are referencing the same global variable. Important notes about extern asterisk. Asterisk you can only define a global variable once. Multiple definitions will result in a linker error. Asterisk you can have multiple extern declarations in different files that want to access the same global variable. Asterisk the extern keyword is not required in the same file where the global variable is defined, but it can be included for clarity. 6. Static keyword with global variables, internal linkage. When the static keyword is used with a global variable, it changes the variable's linkage from external to internal. This means the global variable is only visible within the file where it is defined. It cannot be accessed from other files, even if they have an extern declaration for a variable with the same name. This is useful for creating global variables that are specific to a single file and should not be accessed or modified by other parts of the program. File 1, file1.c. File 2, file2.c. Explanation asterisk. Asterisk file specific global is declared as static int file specific global equals 50, in file1.c. Asterisk because of the static keyword, file specific global has internal linkage and is only visible within file1.c. Asterisk if you try to declare file specific global as extern in file2.c, the linker will not be able to find a definition, resulting in a linker error. 7. Best practices and considerations asterisk asterisk. Asterisk minimize global variables asterisk excessive use of global variables can make code harder to understand, debug, and maintain. They can lead to unexpected side effects and increase the risk of naming conflicts. Favor passing data between functions explicitly, using parameters and return values, whenever possible. Asterisk use static to limit scope asterisk if you need a global variable that is only relevant to a single file, use the static keyword to prevent it from being accessed from other files. This helps encapsulate data and reduces the potential for conflicts. Asterisk initialize variables. Asterisk always initialize local variables to a known value to avoid unpredictable behavior due to uninitialized memory. Global variables are automatically initialized to 0, but it's still good practice to initialize them explicitly for clarity. Asterisk avoid variable shadowing. Asterisk as mentioned earlier, avoid using the same name for local and global variables. Use meaningful and distinct names to reduce the risk of confusion. Asterisk use constants. Asterisk for values that should not be changed, use the const keyword to declare constants. This helps prevent accidental modification of important values. You can also use define for creating symbolic constants, especially when dealing with preprocessor directives. Asterisk choose appropriate scope. Asterisk consider the purpose of each variable and choose the most appropriate scope, local or global, based on its accessibility requirements. Variables that are only used within a specific function should be declared as local variables. 8. When to use global variables, with caution. While minimizing global variables is generally a good practice, there are some legitimate scenarios where they can be useful. Asterisk configuration parameters. Asterisk program-wide configuration options, example debug flags, verbosity levels, can be stored in global variables. These should typically be declared as const if they should not be modified during program execution. Asterisk shared resources. Asterisk access to shared resources like hardware devices or network connections can be managed through global variables. However, proper synchronization mechanisms, example mutexes, are crucial to prevent race conditions and data corruption in multi-threaded environments. Asterisk lookup tables. Asterisk large, read-only lookup tables used by multiple functions can be defined as global variables, often static const to protect them. Asterisk interrupt service routines, ISRs. In embedded systems programming, ISRs often need to access and modify data that is also used by the main program loop. Global variables are often the most practical way to share this data, but careful consideration must be given to interrupt safety and potential race conditions. 9. Conclusion. Understanding the differences between local and global variables is essential for writing well-structured, maintainable, and bug-free C code. By carefully considering the scope and lifetime of variables and following best practices, you can create programs that are easier to understand, debug, and modify. Remember to favor local variables whenever possible, minimize the use of global variables, and always be mindful of potential naming conflicts and side effects. Using static to limit the scope of global variables is a valuable tool for encapsulation. This knowledge will significantly enhance your skills as a C programmer.